Welcome everyone in this knowledge sharing session. In today's session, I am going to cover screw and nut tightening torque. Generally, with this problem, we work day in day out. So first, we start with how to select a screw and nut size. So it's depend on many factors. Some factors are torque requirement, cost, space availability, load requirement. There could be other reason, electrical or availability, anything possible. But few are the few major requirement generally we start with. In the screw we talk about slot drive, head, pitch, screw size. So how to calculate screw and nut tightening torque? Generally screw used to hold two or more parts together. Tightening torque to screw mainly depend on part strength. So if we are selecting any torque, we need to know which is our weakest area. We need to know the strength of component. When we apply high torque, there could be following component may fail, like screw threads here, nut threads here, drive slots here, holding part deformation, head deformation. So we need to know which is our weakest point before selecting tightening torque. In this calculation, we made some assumptions. We are considering thread screw thread only going to share. We considered nut and screw material same, friction coefficient at all component 0.25, only shear stress considered, rest all ignored. There is reason because thread are very small, so other stress is ignored here, mainly shear stress is considered. Before starting calculation, we need to know third parameter like material, tensile strength of material, shear strength of material, screw size, in this case M5, pitch 0.8, number of thread engage. We need to know how many thread engage between nut and screw. Shear dia nothing but screw size minus pitch. So generally this dia considered where shear going to start in thread. Shear chord height means at same shear diameter, what is the height of thread chord. In picture you can see the shear diameter and shear chord height shown here. So in this case shear chord height 0.3, head dia we need to know 9.5, part whole dia we need to know, in this case 5.5. So mean head dia we can calculate. Mean head dia nothing but the area of contact between the screw head and component, so we can easily calculate. So in this case coming 7.5. So what is shear stress? So shear stress is the one special kind of stresses. The formula very same, shear force divided by shear area, but in this case area we consider along the direction of force. So you can consider, you can see here three example, one punch and die, other over the block top surface we are applying the load. One case we glued two component and we are applying tangential load. So in all cases we can need to consider the area along the direction of these forces. So maximum tightening torque in this case, tightening torque is equal to total friction force is to the torque arm. This case friction acting at third area as well as at bottom. Total friction force 2 is to normal reaction is to coefficient of friction. Shear area we can calculate because we know the chord height, we know the total thread of engagement, we know the shear diameter. So we, and with this value we can calculate the total shear area. Shear strength formula we know. So with this formula we can calculate the normal reaction which can this thread mass can withstand. So Nmax we can calculate. So now we can calculate friction force. So 3, so it's coming Nmax by coefficient of friction. So this case 357.75 coming. So now we can start calculating tacking torque. So in this case, because friction acting at two places, so first case head, between the head and component. So F is to the mean head diameter. Second third area, so F is to the shear diameter. So with the help of this calculation, we can calculate 4185.675 Newton mm. So this is the maximum tightening torque this system can withstand. By looking at this formula, you can understand friction playing very big role here. If our friction value is small, then system can withstand very small tightening torque. If friction high, means friction giving big advantage here. If friction high, means you can apply very high amount of load over the system without failing any feature. So thanks for watching this video. For more useful video, please subscribe our YouTube channel Public Knowledge. Thanks again. Have a good day.